It's 1935. American Airlines wants something audacious, a plane that lets passengers sleep in actual beds while flying from New York to Los Angeles. Not cramped seats, not stuffy cabins, but pull-down berths like a Pullman train car at 10,000 feet. They call Donald Douglas, the California aircraft manufacturer who's been tinkering with all-metal designs, and tell him they need 20 sleeper planes. Douglas says yes, but his engineers are sweating. Building a commercial airliner that's both luxurious and profitable is like threading a needle in a hurricane. His team gets to work, and by December 17, 1935, exactly 32 years after the Wright brothers' first flight, the DST, or Douglas Sleeper Transport, takes off from Clover Field in Santa Monica. It's a beauty, all-metal skin, twin engines, a tailwheel and room for 14 sleeping berths or 21-day seats in the standard DC-3 variant. Airlines love it because it's the first plane that can make money flying passengers alone, no mail contracts needed. The DC-3 becomes the backbone of American civil aviation almost overnight. But here's the thing nobody saw coming. This passenger plane designed for comfort and profit has bones built for punishment. The fuselage is a semi-monocoque structure, meaning the metal skin itself carries stress loads instead of relying solely on an internal frame. That makes it light but incredibly strong, like an aluminum beer can that refuses to crumple. The wings are thick, with a high-lift airfoil design that lets the plane take off and land on short runways, crucial for the grass strips and rough fields that pass for airports in the 1930s. Douglas engineers also gave it a wide center section between the wing spars, creating a spacious cargo hold that could swallow luggage, mail sacks, or, as they'd discover later, jeeps, howitzers, and wounded soldiers on stretchers. The landing gear is rugged, designed to absorb hard bounces on unpaved strips, and the tailwheel setup makes it stable on the ground, even in crosswinds. By 1939, DC-3s are flying 90% of the world's airline traffic. Over 400 are in service, connecting cities across America, Europe, and Asia. Pan American is using them to open routes in Latin America. KLM is flying them to the Dutch East Indies. It's the first true global airliner, and it's making aviation accessible to middle-class travelers, not just the wealthy elite. Then the world catches fire. Germany invades Poland in September 1939, and suddenly everyone realizes that wars aren't won just by fighters and bombers. You need transport planes to move troops, supplies, and equipment fast. The US Army Air Corps has been watching the DC-3 for years, and they're intrigued. This civilian bird can haul 3 tons of cargo, cruise at 160 miles per hour, and operate from rough fields. It's not designed for war, but it has all the traits a military transport needs: reliability, simplicity, and toughness. The brass starts making phone calls to Santa Monica. December 1941 changes everything. The Japanese attack Pearl Harbor on the 7th, and suddenly the United States is fighting a 2-ocean war with nowhere near enough equipment. The Army Air Forces need transport planes immediately. Not in 6 months, not after a lengthy development program, but now. They already know the DC-3 works, so instead of designing something from scratch, they make a simple decision: militarize it. On paper, it sounds straightforward. In reality, Douglas engineers have 72 hours to turn a luxury airliner into a cargo hauler that can survive combat conditions. The comfortable sleeper berths get ripped out. Gone are the soundproofing panels, the plush seats, the overhead bins for passenger luggage. In their place, Douglas installs reinforced aluminum floors rated to handle concentrated loads, think ammunition crates, fuel drums, or a fully assembled motorcycle. They add a massive cargo door on the port side, 6 feet tall and wide enough to load a disassembled jeep or a 75mm pack howitzer broken into pieces. This isn't a gentle modification. They're cutting into the fuselage structure and reinforcing the edges with heavy frames to prevent cracking under stress. The military also demands seats for paratroopers, 28 men in full combat gear facing each other along the cabin walls on fold-down benches made of tubular aluminum and canvas webbing. These aren't comfortable, they're not supposed to be. They need to be light, strong and fast to install. Above the seats, Douglas adds a steel cable anchor line running the length of the cabin ceiling. Paratroopers will hook their static lines to this cable, and when they jump, the line yanks their parachutes open automatically. It's a brilliant piece of simplicity, but it requires precise engineering. The cable has to handle 28 men pulling on it simultaneously during a drop without tearing loose from the airframe. The floor also gets tie-down rings every few feet. Heavy steel loops bolted through the skin into the underlying structure. You can lash down cargo with chains or ropes, and it won't shift during turbulence or hard maneuvers. The pilots get small upgrades too, more robust instruments, a better compass, and astrodome hatches for celestial navigation on long overwater flights. They also add a 24-volt electrical system instead of the civilian 12-volt setup, powering radios and signal lights that can talk to ground troops. The redesigned plane gets a new designation, C-47 Skytrain. The C stands for cargo, and 47 is just the next number in the Air Force's sequential list. Douglas doesn't change the engines, the wings, or the landing gear. There's no time, and frankly, no need. The civilian DC-3 structure is already overbuilt by airline standards, which makes it perfect for military abuse. By January 1942, the first C-47s are rolling off the production line at the Long Beach plant. Douglas also fires up a second factory in Oklahoma City to meet demand. The Army orders 965 planes initially, then raises it to 5,000, then keeps going. Workers are building them 24 hours a day in shifts, and the factory floor looks like controlled chaos. Wings being riveted, engines lowered onto mounts, fuselages moving down the line like a morbid assembly of aluminum insects. Each plane takes about 20,000 man-hours to complete, which sounds like a lot until you realize Boeing's B-17 bomber requires triple that. The C-47 is fast to build, cheap to operate, and nearly impossible to break. The heart of the C-47 is a pair of Pratt & Whitney RNT-30 twin Wasp engines, and understanding why these specific power plants mattered is key to understanding why the plane dominated. Each engine is a 14-cylinder air-cooled radial, meaning the cylinders are arranged in a circle around the crankshaft, like the petals of a flower. This layout has huge advantages. Air-cooled engines don't need radiators, coolant lines, or pumps, which means fewer things to break and less weight to carry. In combat zones where a single bullet through a coolant line can kill a liquid-cooled engine, the twin Wasp just keeps running. Each engine produces 1,200 horsepower at takeoff, and while that's not earth-shattering compared to fighter planes, it's exactly the right amount for a transport. Too much power, and you're wasting fuel. Too little, and you can't lift a full load out of a short jungle strip. The twin Wasp hits the sweet spot. But here's where Douglas engineers earned their paychecks. They didn't just bolt these engines onto the wings and call it a day. They designed engine mounts that absorb vibration, because radial engines shake like jackhammers. The mounts use rubber isolators that let the engine wobble slightly without transmitting every shudder into the airframe. This keeps rivets from working loose and prevents metal fatigue cracks that would ground the plane after a few hundred hours. They also added full feathering propellers, a feature borrowed from bombers. If one engine fails, the pilot can rotate the dead propeller blades edge-on into the wind, eliminating drag. The C-47 can fly on one engine. Not well, not fast, but it'll limp home instead of dropping out of the sky. Pilots love this because engine failures were common over hostile territory, and single-engine flying saved hundreds of crews. The fuel system is another masterpiece of practical engineering. The C-47 carries 804 gallons of aviation gasoline split between 4 tanks, 2 in the wings, 2 in the center section. Gravity feeds fuel from the wing tanks to the engines, so even if the electric fuel pumps fail, the engines keep running as long as there's gas in the tanks. For long-range missions, ground crews can strap auxiliary fuel tanks inside the cargo cabin, extending range from 1,600 miles to over 3,000. This turns the C-47 into a transoceanic transport, capable of island hopping across the Pacific or flying the South Atlantic route from Brazil to West Africa. The plane burns about 100 gallons per hour at cruise speed, which seems thirsty until you realize it's hauling 3 tons of cargo while doing it. The fuel efficiency per ton-mile is better than almost any truck convoy, and infinitely faster. The reinforced cargo floor is the unsung hero of the design. Douglas took the original DC-3 floor and added heavy longitudinal beams running front to back, plus crossmembers every few feet. The floor can now handle 6,000 pounds of cargo concentrated in a small area. Imagine stacking ammunition crates in one corner without crushing the structure. The floor is also slightly crowned, higher in the middle than at the edges, so water and mud drain toward the door instead of pooling inside. Little details like this made the difference between a plane that worked and one that became a maintenance nightmare. The floor is covered in non-slip plywood panels that ground crews can replace in an hour if they get damaged. Nothing fancy, nothing complicated, just smart design executed flawlessly. When you add it all up, the engines, the fuel system, the floor, the structure, you get a plane that's almost idiot-proof, and in wartime that's worth more than raw performance. June 6, 1944. The world holds its breath as Operation Overlord unfolds across the Normandy coast. But hours before the first landing craft hit the beaches, the real opening move happens in the night sky over France. At 12:15 a.m., 822 C-47s lift off from airfields across southern England, their fuselages packed with American paratroopers from the 82nd and 101st Airborne Divisions. Each plane carries 18 to 20 fully loaded troopers men, wearing 80 pounds of gear, weapons, ammunition, and reserve parachutes. The cabin is cramped, dark, and smells like sweat, oil, and vomit because half these guys are airsick from the turbulence. The pilots are flying in tight formations called serials 9-plane Vs stacked behind each other, navigating by dead reckoning and occasional radio beacons because German radar makes electronic navigation suicidal. They're crossing the English Channel at 1,500 feet, low enough that engine noise echoes off the water. The plan is elegant on paper. Drop 13,000 paratroopers inland behind Utah Beach to secure bridges, destroy artillery positions, and block German reinforcements. The Pathfinders jump first at 12:15 a.m. to set up radar beacons and lights marking the drop zones. Then the main waves follow, each serial timed to arrive at precise intervals. But war never goes according to plan. As the C-47s approach the French coast, German anti-aircraft guns open up tracer rounds arc through the darkness. 88mm flak shells burst in orange fireballs, and suddenly pilots are taking evasive action, diving, climbing, twisting to avoid the fire. The tight formations disintegrate. Some pilots slow down to 90 miles per hour, worried about flying too fast and injuring jumpers in the propeller blast. Others punch the throttles to 150 to escape the flak. The result is chaos. Paratroopers jump into the darkness with no idea where they are. Some land in flooded fields and drown under the weight of their equipment. Others come down in trees, on rooftops, or in the middle of German positions. But here's the thing, the C-47s keep flying. Planes take direct hits, shrapnel tears through aluminum skin, hydraulic lines rupture, engines catch fire, yet the majority limp back to England. Crews report bullet holes in the wings, tail sections shot half away, control cables hanging by threads. One C-47 returns with 108 holes in the fuselage and both engines barely running. The plane lands, gets patched overnight, and flies again the next day. The dispersion problem actually works in the Allies' favour. German commanders receive reports of paratroopers landing everywhere behind every hedge, in every village, and they panic, thinking the invasion is larger than it actually is. Small groups of Americans coalesce in the darkness, using toy crickets to identify each other and begin attacking objectives. By dawn, despite the scattered drops, paratroopers have seized key bridges and roads. The C-47s return at daylight on June 6th, this time towing Waco gliders loaded with jeeps, anti-tank guns, and more troops. The gliders are flimsy plywood boxes, and landing them in small French fields is a death sentence for many, but the C-47 tugs get them there. Over 500 gliders land on D-Day, delivering artillery and vehicles that paratroopers couldn't carry. The C-47 crews fly multiple missions that day, dropping troops, towing gliders, evacuating wounded on return flights. Pilots are exhausted, navigators are hoarse from shouting coordinates, and every plane smells like cordite and blood. But the mission succeeds. Normandy's drop zones become footholds, and those footholds become the breakout that liberates France. Eisenhower himself later says the war couldn't have been won without the C-47, not the fighters, not the bombers, the unarmed transport doing the dirty work. The C-47 doesn't rest after Normandy. 10 months later, on March 24, 1945, it's back in the spotlight for Operation Varsity, the airborne assault across the Rhine River into Germany's industrial heartland. This time, the planners learn from D-Day's mistakes: no night drops, no scattered formations. Over 900 C-47s and British equivalents take off in broad daylight at 10 a.m., flying in parade ground precision. They drop 17,000 British and American paratroopers in under 2 hours, the most concentrated airborne assault in history. German flak is murderous because daylight gives gunners clear targets. 53 C-47s get shot down over the drop zones, spinning into the German countryside in flames. Another 400 return to base so badly damaged they're written off or need weeks of repair. But the mission works. Paratroopers land together, organized and ready to fight, and they seize the bridgeheads that let ground forces pour across the Rhine. The C-47 proves it can absorb punishment that would obliterate lesser designs and still deliver the payload. Meanwhile, 6,000 miles away in the Pacific, C-47s are fighting a completely different war. Jungle airstrips in New Guinea, the Philippines and Burma become lifelines for troops cut off from naval supply routes. These aren't proper airfields, they're hacked out of rainforest, covered in pierced steel planking or crushed coral, barely 2,000 feet long with trees at both ends. The C-47 doesn't care. Its wide landing gear spreads weight across soft ground, and the tail dragger configuration means the tailwheel acts like a brake on rollout. Pilots routinely land with one engine feathered, dodging Japanese fighters on the way in, dump cargo, load wounded, and take off again before enemy artillery can zero in. In Burma, C-47s supply the Chindits, British long-range penetration units operating 200 miles behind Japanese lines. There are no roads, no rivers navigable by boat, just jungle. The C-47 crews fly over the Himalayas on the southern edge of the route called the Hump, crossing 16,000-foot mountain passes, where updrafts and downdrafts slam planes around like toys. They're hauling ammunition, food, medical supplies, and mules, yes, live mules, for the Chindits to use as pack animals. Loading a terrified mule into a C-47 cargo bay is its own special nightmare, but crews manage. They also evacuate wounded, sometimes packing 30 stretchers inside by stacking them 3 high along the cabin walls. The cabin becomes a flying field hospital, medics working by flashlight while the plane bucks through monsoon storms. The most famous Pacific mission is the supply run to Bataan in early 1942, before the Philippines fall. C-47s flying from Australia attempt to break through Japanese air patrols and drop food and ammunition to trapped American and Filipino forces. Most don't make it. Japanese Zeros shoot them down or force them to turn back, but a handful slip through at night, flying at wave-top height to avoid radar, and drop supplies that keep the defenders fighting for a few more weeks. It's a suicide mission, and everyone knows it, but the crews volunteer anyway. Later, after MacArthur retakes the Philippines, C-47s become the backbone of island-hopping logistics. They leapfrog from one captured airstrip to the next, delivering everything from fresh water to propaganda leaflets. On Okinawa, they land under artillery fire, engines running, Cargo doors open, ground crews throwing supplies out while the plane is still rolling. The average turnaround time is 4 minutes. This kind of efficiency doesn't come from the plane alone, it comes from the simplicity of the design that lets mechanics fix problems with basic tools and lets cargo handlers work fast. The C-47 doesn't demand specialized equipment or pristine conditions. It just works everywhere, every time. The war ends in August 1945, and suddenly the world is flooded with surplus C-47s. Thousands sit on airfields from England to the Philippines, waiting to be scrapped or sold off cheap. Most military aircraft fade into obscurity after their wars end, but the C-47 gets a second act that's almost as dramatic as the first. In June 1948, the Soviet Union blockades West Berlin, cutting off all road and rail access in an attempt to starve the city into submission and force the Western Allies out. 2 million Berliners are trapped in the western sectors, with maybe 36 days of food stockpiled. The city needs 4,500 tons of supplies every single day, just to survive: coal for heating and electricity, flour for bread, medicine, clothing, everything. Supplying an entire city by air seems impossible. Nobody's ever tried it. But the Allies don't have a choice. So they dust off the war surplus C-47s and start flying. Operation Victuals, as the Americans call it, begins on June 26, 1948. The British call it Operation Plain Fare. At first, it's a disorganized scramble. C-47s flying whatever cargo they can scrounge, landing at Tempelhof Airport in the heart of Berlin, unloading by hand and flying back. The planes can carry about 2.5 tons per trip, which means they need nearly 2,000 flights per day to meet the city's needs. That's one plane landing every 90 seconds, around the clock, in all weather. The logistics are staggering. Ground crews develop a system. The moment a C-47 touches down, it taxis to the unloading zone, where German workers swarm it. They've got 8 minutes to unload the cargo: coal sacks, flour bags, powdered milk crates, before the plane has to take off and clear the runway for the next arrival. If a plane breaks down, they push it off the runway with a bulldozer and fix it later. There's no time for anything else. The C-47s fly in 3 corridors from West Germany into Berlin, each corridor 20 miles wide and stacked with altitude layers. Planes fly at 5,000, 6,000 and 7,000 feet, separated by time intervals calculated down to the second. Air traffic controllers are managing a 3-dimensional ballet that would give modern logistics experts nightmares. Winter makes everything worse. Berlin, in December 1948, is freezing, and the city's power plants are running out of coal. The C-47s start hauling coal, almost exclusively dirty, heavy, abrasive stuff that wears out the cargo floors and clogs the cabin with black dust. Crews shovel coal out of the plane between flights because there's no time to sweep properly. They're exhausted, flying 2 or 3 round trips per day, sleeping in shifts, eating cold rations. The planes are taking a beating too. The constant flying wears out engines faster than peacetime operations ever did. Maintenance crews work 20-hour shifts, replacing cylinders, patching hydraulic leaks, swapping out propellers bent from hard landings. By spring 1949, the airlift is a well-oiled machine. The Allies add larger C-54 Skymasters to the fleet, but the C-47 remains the workhorse, flying the majority of missions. On Easter Sunday, April 16, 1949, the airlift sets a record: 12,491 tons delivered in 24 hours, nearly 1,400 flights. Stalin realizes he's not going to break the Allies' will, and on May 12, 1949, he lifts the blockade. The airlift continues until September just to build up Berlin's reserves, and when it finally ends, the C-47s have flown over 100,000 sorties and delivered 2.3 million tons of supplies. Not one Berliner starved. The C-47 proved it could do in peacetime what it did in war: sustain life under impossible conditions. The planes that dropped paratroopers into Normandy now drop coal into a blockaded city, and they do it with the same rugged reliability. The C-47's influence doesn't stop at American borders. It spreads across the globe like a contagion, and countries everywhere realize they need this plane. The British receive over 2,000 C-47s through Lend-Lease during the war and fall in love with them. They rename it the Dakota, a nickname born from the military designation Douglas Aircraft Company Transport Aircraft, or Dakota. The name sticks, and to this day British pilots still call it the Dakota with a kind of reverence. The Royal Air Force uses Dakotas everywhere: North Africa, Italy, Burma, and later in Malaya, fighting communist insurgents in the jungle. The plane's ability to drop supplies to remote outposts deep in the rainforest makes counterinsurgency possible. Without the Dakota, the British probably lose Malaya. France gets hundreds of Dakotas after the war and immediately puts them to work in Indochina, supplying isolated garrisons fighting the Viet Minh. The most famous mission is Dien Bien Phu in 1954, where French Dakotas desperately airlift supplies and paratroopers into a valley surrounded by enemy forces. The base falls anyway, but the Dakotas fly until the last possible moment, crews knowing they're likely flying into captivity or death. Then there's the Soviet story, and it's wild. In 1936, before the war even starts, the Soviets buy a license to build DC-3s domestically. They reverse engineer the design, convert all the measurements from inches to metric, and start producing a clone called the Lisunov Li-2. It's almost identical, except they add a dorsal gun turret, because Soviet military doctrine assumes every transport will get jumped by enemy fighters. By the time Germany invades in 1941, Soviet factories are cranking out Li-2s, and they build over 6,000 by war's end. The Li-2 does everything the C-47 does. Supplies partisans behind German lines, evacuates wounded from Stalingrad, and even flies as a night bomber, dropping small bombs on German positions. After the war, the Soviets export Li-2s to every communist nation on Earth. China gets them, North Korea uses them in the Korean War, and Eastern European countries fly them for decades. There's a weird irony in a Soviet-built clone of an American capitalist airliner, becoming the backbone of communist military logistics, but that's exactly what happens. Smaller nations adopt the C-47 because it's cheap, simple, and available. After World War II, you can buy a surplus C-47 for the price of a nice car, and operating it doesn't require a team of specialized engineers. A mechanic who can fix a tractor can fix a C-47. Countries like Greece, Turkey, Israel, and South Africa build their air forces around the type. Israel uses C-47s in the 1948 War of Independence to airlift supplies past Arab blockades, and even converts a few into improvised bombers by rolling explosives out the cargo door. It's crude, but it works. South Africa flies C-47s in the border war, inserting troops into Angola and Mozambique. The Argentine Air Force uses them in the Falklands War in 1982, yes, nearly 50 years after the design's debut. They're still flying combat missions. One Argentine C-47 gets shot down by a British Sea Harrier, probably the only time a 1930s transport has been killed by a jet fighter. By the 1990s, over 60 nations have operated C-47s or Dakotas at some point, making it one of the most widely used aircraft in history. Some are still flying today, mostly with small cargo operators in Africa and South America, hauling freight to places where paved runways are a luxury. There are C-47s built in 1943 that have logged 90,000 flight hours, equivalent to flying non-stop for over 10 years. The airframe just refuses to quit. Walk into any modern military transport, C-130 Hercules, an A400M Atlas, even a massive C-17 Globemaster, and you'll see the C-47's DNA everywhere. The rear cargo ramp that drops down for loading? That's an evolution of the C-47's side cargo door philosophy. Make it fast to load and unload without specialized equipment. The webbing seats along the fuselage walls where troops sit facing each other? Direct descendant of those tubular aluminum benches Douglas installed in 1942. The tie-down rings in the floor, the static line cables for paratroopers, the emphasis on operating from rough fields. Every modern military transport inherits these features because the C-47 proved they work. The US Air Force's entire doctrine of tactical airlift, the idea that you can sustain ground forces deep in enemy territory purely through air supply, was written during World War II with C-47s as the test platform. Before the C-47, nobody believed you could run a war without secure supply lines on the ground. The C-47 made that belief obsolete. The engineering lessons went even deeper. Douglas proved that you didn't need cutting-edge technology to build a war-winning weapon. You needed reliability, simplicity, and ease of production. The C-47 used off-the-shelf engines, conventional aluminum construction, and mechanical systems a high school shop class could understand. There were no exotic materials, no experimental designs, no components that required months of lead time to manufacture. This design philosophy influenced post-war military thinking profoundly. When Lockheed designed the C-130 Hercules in the 1950s, they deliberately mimicked the C-47's approach: robust, simple, maintainable in the field with basic tools. The C-130 became the C-47's spiritual successor, and it's still in production 70 years later for the same reasons the C-47 lasted. It just works. Modern logistics officers still study the Berlin airlift as the gold standard for sustained aerial supply operations. The coordination, the maintenance schedules, the traffic control procedures developed in 1948 with C-47s became the template for every major airlift since, from Vietnam to Iraq to Afghanistan. But the C-47's legacy goes beyond military hardware. It fundamentally changed how the world thinks about transportation. Before the DC-3 and its military offspring, air travel was exotic and unreliable. After World War II, thousands of surplus C-47s flooded the civilian market and became the workhorses of commercial aviation in developing nations. These planes opened air routes across Africa, South America, and Asia, connecting remote regions that had no roads or railroads. The C-47 proved that aviation could be rugged, affordable, and dependable, not just a rich person's toy. That psychological shift mattered. It convinced governments and businesses to invest in aviation infrastructure, which eventually led to the jet age and modern global connectivity. In a very real sense, the C-47 is the grandfather of the Boeing 737 and Airbus A320 that connect the world today. There's something poetic about a plane designed to carry sleeping passengers in luxury, becoming the machine that won the war and then rebuilt the peace. The engineers at Douglas in 1935 had no idea their sleeper transport would drop paratroopers into France, supply guerrillas in Burma, feed a blockaded city and still be flying 90 years later. They just built the best plane they could with the technology available, and it turned out that good enough done right beats cutting edge almost every time. The C-47 didn't win the war because it was the fastest or the most advanced. It won because it showed up, did the job, took the damage, and came back for more, day after day, mission after mission, year after year. That's the legacy, not just an aeroplane, but a philosophy of engineering that values reliability over brilliance, simplicity over complexity, and proven capability over untested innovation. The C-47 Skytrain taught the world that sometimes the best tool is the one that simply refuses to break, and that lesson still echoes through every cargo plane flying today.